Driveline axles. Program agenda. In this topic, we are going to learn about shaft and axles, shaft and axle components, types of axles, front and rear axles, lift axle system, differential components, types of differentials, introduction to Eicher tandem rear axle, and interlock differential lock. Introduction to shaft and axles. Introduction to shaft. In previous module, we have learnt about clutch and transmission system in automobiles. The power produced by the engine is transferred to the wheels through the clutch transmission, and then to drive lines like propeller shaft and axles. The driveline of a motor vehicle consists of the parts of the powertrain, excluding the engine and the transmission. The driveline is a system of components including shafts, axles, and differential. These components work together to deliver the power to the wheels. In this module, we will learn and understand about drive shafts and axles. Types of shafts. Shafts are used to transfer the drive torque from the transmission, that is, output shaft or transfer case, to the driven wheel, generally called drive shafts or propeller shafts. Since the drive torque is to be transmitted at a distance between the driving and the driven members, certain variations will be allowed in the alignment by incorporating the universal joints, slip joints, and CV joints in a drive shaft or propeller shaft. Shafts can be broadly classified into two main categories: propeller shafts and drive shafts. Layout of shafts in a vehicle. Front-wheel drive shaft. In front-wheel drive vehicle layouts, the drive shafts are located between the transaxle and the drive wheels. Rear-wheel drive propeller shaft. In a rear-wheel drive, the engine torque is transmitted to the rear differential via a propeller shaft. The differential then transfers the torque to the drive wheel through the drive axles. Layout of shaft in commercial vehicles. In the commercial vehicle segment, mostly rear-wheel drive system is used, that uses the propeller shaft to transmit the power to drive wheels. Propeller shaft and components. A propeller shaft is a bulky, long, tubular mechanical component made of hollow steel, aluminum, or composite materials that connects the transmission and the differential in a rear-wheel drive layout. The shaft is connected to the transmission and the differential with the help of universal joints at both ends, and a slip joint that help in accommodating the increase in height or length when traveling over an uneven surface with minimum or no loss of power. Generally seen in rear-wheel drive vehicles and all-wheel drive vehicles. On commercial vehicles with larger wheelbase, there will be 3 propeller shafts. Components of propeller shaft. On the screen, you can see a breakdown of various components of the propeller shaft. The main components are flange, slip yoke, prop shaft tube, retainer ring, and spider. Next, you will learn about these components in detail. Propeller shaft components. Slip yoke. The slip yoke connects the transmission to the propeller shaft. It also connects one propeller shaft to another in multi-shaft application. Consists of internal splines which match with the external splines of shaft. Universal joint. The universal joint provides flexibility to the propeller shaft and is located between the prop shaft to the sleeve yoke. It consists of 2 Y-shaped yokes that are joined together by the spider and supported by needle roller bearings. The bearings are lubricated for life. Prop shaft tube. Made of hollow or solid steel, aluminum, or composite materials, and connects between the transmission output shaft and the differential in the case of a rear-wheel drive layout. It is an extension of transmission output shaft. Needle roller bearing. It is the part of the spider assembly. The spider assembly is connected to the yoke assembly through the needle roller bearings, which eases the motion of the universal joint and spider assembly. Pinion flange. Pinion flange connects the rear U-joint and axle pinion flange to transmit the rotational torque to the axle. Consist of internal splines which match with the external splines on the prop shaft. Retainer ring. The retainer ring is located between the propeller shaft slip yoke and the universal joint. The main function of the retainer ring is to hold both the components together when in operation. Drive shaft components. A drive shaft is a long, tubular, solid or hollow mechanical component made of steel that is used to transmit engine torque to road wheels. It is located between the transaxle and the driven wheels in the front-wheel drive layout, and between differential and driven wheels in the all-wheel drive layout. The shaft consists of splined ends and constant velocity joints or CV joints on both sides. The inner joint is completely flexible and has the ability to move in and out. The outer joint is also flexible, but it cannot move in and out. The CV joint is designed to accommodate the change in height and transfer the same amount of torque to the drive wheels when the vehicle is moving over a rough patch. Caulking nut. A caulking nut is a hexagonal nut which is used to fasten the drive shaft to the front disc rotor in the case of a front-wheel drive vehicle. Also, it is used to fasten rear drum assembly to the axle. The nut needs to be locked to the drive shaft by hammering the edge of the nut into the slot on the drive shaft end with the help of an appropriate tool. This will help to prevent it from loosening accidentally. Constant velocity or CV joint. ACV joint is located between the axle shaft and the road wheels. It allows the drive shaft to transmit power through a variable angle at constant rotational speed without an appreciable increase in friction or play. They are mainly used in the front-wheel drive and all-wheel drive cars. Axle shaft. This is a solid or hollow rod that connects between the inner and the outer CV joints. Seal retaining clamp. The seal retaining clamp is placed over the sealing boot. It is used to lock the sealing boot to the drive shaft end to prevent leakage of grease or lubricant from the boot or prevent dust entering the boot. It is needed to ensure that the clamp is suitably tightened. Drive axle outboard and inboard seal. The drive shaft is an underbody component. It is exposed to dust and mud. The drive axle outboard seal, also known as a boot, is a rubber component that is used to seal the CV joint from exterior dust or mud. Drive axle inboard seal. Drive axle outboard. The drive shaft is an underbody component. It is exposed to dust and mud. The drive axle outboard seal, also known as a boot, is a rubber component that is used to seal the CV joint from exterior dust or mud. Cross groove joint. This is the joint which connects the drive shaft axle to the transaxle. Two types of joints are available in this, male and female types. Some manufacturers allow replacement of this joint separately. Retaining ring. This retaining ring locks the drive shaft to the differential output. Race retainer ring. A race retaining ring, commonly known as circlip, is used to fasten the CV joint to the axle shaft. The ring can be expandable or compressible type based on the place of application. Introduction to axles. What do we mean by an axle? Imagine a wheel without an axis for rotation. In old days, people used to fetch water from the well using the pulley. Can you tell me where is the axle? The center point where the pulley is hinged is the axis or the axle. In automobiles, we use axles for the wheels to rotate. The engine power is transmitted to the wheels using the axles. Flow of engine power to wheels. In the animation shown on the screen, you can see how the engine power rotates the wheels. Here, power from the engine rotates the drive shaft, which in turn rotates the differential, and the differential distributes the rotational energy individually to both the wheels through the axles. Types of axles. The axles can be broadly classified into front and rear axles. Both the axles can be further divided into live and dead axles. Dead axles. Dead axles are those axles which do not rotate. They do not transmit the power from the transmission to the wheels. These axles have sufficient rigidity and strength to take the weight. The ends of front axle are suitably designed to accommodate stub axles. Live axles. The live axles are those which transmit the power from the gearbox to the wheels and they rotate. Depending on the design and load carrying capacity, These are further classified into semi-floating and fully floating axles. Let us look at the pictures of the front and rear axles. Types of front axle. There are two types of front axles. Reverse Elliott type. The reverse Elliott front axles have hinged spindle yoke on spindle itself, instead of on the axle. The forked portion is integral with the steering knuckle. Elliott type. In the Elliott type front axles, the yoke for king spindle is located on the ends of I-beam. The axle ends are forked to hold the steering knuckle extension between them. Main parts of front axle. The main parts of the front axle are shown on the screen. They are the axle beam, stub axles with brake assemblies, tie rod, and steering arms. Here is a close-up look of the front axle indicating the main parts. Types of rear axles. Rear axle is classified into three types based on the load carrying and design aspects. They are semi-floating, three-quarter, and fully floating axles. Semi-floating axles. By design, a semi-floating axle uses a wheel hub that is directly connected to the axle shaft. The hub and axle shaft are commonly a single part, which is supported by a bearing located near the wheel end of the shaft. As such, the weight of the vehicle and any cargo must be carried by the axle shaft itself. Therefore, the axle shaft is used to transmit power to the wheel as well as support the load of the vehicle, applying both bending and torsional forces to the axle. Semi-floating axles are both lighter in weight and cheaper to manufacture than full-floating axles, though they have a limited load capacity. They are very common in light-duty vehicles such as mid-size and 1 or 2 ton pickups. Three-quarter floating axles. In this type of axles, the wheel hub is supported by the single bearing located in the center of the wheel hub. The wheel hub runs on the axle housing. The axle shaft is keyed rigidly to the wheel hub. This arrangement provides the driving connection and maintains the alignment of the wheel. The axle has a wheel flange that bolts to the hub and provides lateral support for the hub and wheel, while the bearing assembly supports the weight of the vehicle. The axle also provides the twisting force for the wheel. This arrangement is generally considered heavier duty than the semi-floating axle, but lighter duty than the full floating axle. Not used much nowadays. Fully floating axles. A full floating axle consists of a wheel hub that is separate from the axle shaft. A spindle bolted to the axle tube supports the wheel hub by means of a pair of wheel bearings. Therefore, the weight of the vehicle and its cargo is transferred to the axle tube, rather than the axle shaft itself. As a result, a full floating axle shaft is not subjected to the bending force that a semi-floating axle is. Rather, the axle shaft's only task is to transmit power to the wheel hub. As a result, the shaft is only subjected to torsional loading. Full floating axles are rather heavy, but have very large weight carrying capacities. They are common on 3 to 4 ton and heavier trucks, which require the ability to transport considerable weight and largely used in modern trucks. Introduction to lift axle system. What is a lift axle? By now, you all have understood what an axle is, and how many types of axles are used in automobiles. Now, can you tell me what do you mean by a lift axle? By looking at this animation, what do you understand? As the name itself indicates, a lift axle is an axle which can be lifted. As you have seen in the animation, the lift axle remains lifted in empty or partial load conditions, and it lowers down in fully load conditions. Purpose of lift axle. The purpose of the lift axle is to place the vehicle's total weight over a broader area, thereby allowing the vehicle to meet weight-imposed restrictions on certain roads. Lift axle reduces tire wear and improves fuel economy by reducing rolling resistance in empty condition. By applying air pressure to the lift axle, the driver is able to add one more axle into the system and relieve some of the weight being supported by the other axles. Axles are self-steerable, but does not transmit power. Classification of lift axles. Depending upon its location with respect to the tandem axle, lift axles are classified as tandem axle. It is the main load-carrying axle, and also part of the powertrain. Pusher axle. It is installed in the front of the tandem axle. Tag axle. It is installed in the rear of the tandem axle. It has 3 merits. Prevents unnatural tire wear due to carrying heavy loads. Prevents damage to roads and bridges by distributing the load over an extended area. Reduces wear and tear of the main axle by providing additional support. Working of lift axle. Lift axles uses air bellows to carry the additional load from the main axles. When the air bellows are filled up with air, it pushes the axle down to the road, carrying a part of the load. It distributes the load among the lift axles. Inline air springs help in retraction of the axle when not needed. Air springs help in the lowering and retracting of the axle. Lift axle system. Layout. According to the arrangement of the lift and layout, the lift axles are classified into lift system and para-reverend system. Lift system. Lift system can be used to raise and lower the lift axle. It will automatically lower on a preset load. It can also be controlled manually using the manual override feature. Lift system layout. The layout of components is shown on the screen. Functional description. Load sensing valve creates a pressure signal to the lift control valve. This is limited to a maximum 6.3 bars by the regulator. Axle will lower when signal is above 4.5 bars. It will raise when signal is below 2.4 bars. When the axle is raised, the pressure switch illuminates the axle lifted light. Introduction to differential system. Power flow from the engine. Let us once again look at the layout of how the engine power is transmitted to the rear wheels in a vehicle. You have learnt earlier that the engine power is transmitted to the wheels via clutch, transmission, drive shaft, and finally the differential. The differential is the mechanism which splits the engine power and torque to both the rear wheels in the rear wheel drive vehicles and front two wheels in the front wheel drive vehicles. Let us learn now about the differential in detail. Working of differential. The differential is an integral part of all four-wheelers. It is a device that splits the engine torque two ways, allowing each output to spin at a different speed. It works with both drive axles at the same time, but lets them rotate at different speeds, so that the vehicle can make turns. When a four-wheeler makes a turn, the outer wheel has to turn faster than the inner wheel. Due to the difference in the length of the paths they take, different speeds of the axle shaft are achieved by differential mechanism. The differential is located between the two wheels and is attached to each wheel by an axle shaft, rotated through a bevel gear. Differential changes the direction of rotation of the propeller shaft by 90 degrees to rotate axle shaft. Purpose of differential. In vehicles without a differential, such as carts, both driving wheels are forced to rotate at the same speed, usually on a common axle, driven by a simple chain drive mechanism. When cornering, the inner wheel needs to travel a shorter distance than the outer wheel. So, with no differential, the result is the inner wheel spinning, and the outer wheel dragging, and this results in difficult and unpredictable handling, damage to tires and roads, and strain on or possible failure of the entire drive train. A vehicle's wheels rotate at different speeds, mainly when turning corners. The differential is designed to drive a pair of wheels with equal torque, while allowing them to rotate at different speeds. Let us watch a video of old times, where the differential purpose and functions are very well explained.
Formations like these require long hours of intensive drilling and careful judgment. When the troop goes around the corner, the riders on the outside of the turn have to adjust their speed to keep even with the riders on the inside. The man on the outside has to ride a lot farther and a lot faster in order to keep up with the parade. The outside wheels must spin faster than the wheels on the inside because they have a greater distance to travel in the same length of time. When a wagon turns a corner, the wheels can travel at different speeds because each one can turn freely on the axles. And in the early automobiles, the rear wheels turned separately and only one wheel was connected to the engine. But when only one wheel was driven by the engine, it had to do all the work. and it couldn't get a good enough grip on the road to do its job properly. So the one-wheel drive was soon out of date. But if two wheels are locked on an axle so that they are not free to turn separately, one or the other.
Functions of differential. The main function of the differential is to transfer the engine power from the drive shaft and split the torque to the wheels. Other functions of differential are as follows. Allows the wheels to rotate at different speeds in turns through the differential action. Provides final gear reduction, thereby generating higher torque at wheels. The differential changes the direction of rotation of the propeller shaft by 90 degrees to rotate the axle shaft. Working of differential video.
So engineers had to find a way to connect both rear wheels to the engine without sliding and slipping on turns. The device which makes this possible is a part of the rear axle. It is called the differential because it can drive the rear wheels at different speeds. The differential looks complicated, but once we understand its principle, it is amazingly simple. These two wheels are mounted on separate axles and supported by a frame so that they can revolve freely at different speeds. Let's fasten a spoke on the inner end of each axle so that by turning the spokes, we can turn each wheel separately. With a bar or crosspiece, we can turn both wheels in the same direction at the same rate of speed. Let's get something to hold this bar in place so that it will press against the spokes. Notice that this support is not locked to the axle. It turns freely. Now, we can spin the wheels by rotating the support. This is fine, as long as both wheels are able to turn at the same speed. But let's see what happens when we go around the corner. With this arrangement, we cannot drive one wheel faster than the other. And if we stop one wheel, the other wheel won't budge. Let's put this bar on a pivot so that it can swing in either direction. Now, the bar can still turn both wheels at the same speed. And because it pivots, it lets one wheel turn even when the other is stopped. But if turned too far, the bar will swing around until it won't drive the spokes that turn either wheel. We need another crossbar and more spokes to carry on the job. When we stop one wheel, the crossbars will continue to push the spokes of the free wheel around. As long as both wheels are free to turn, the bars do not swing on their pivot, and the wheels move at the same speed. Now we have the working principles of a differential. To adapt the model for use in an automobile, we will have to make a few changes. In order to reduce the jerky action caused by wide spaces between the spokes, we will put in more spokes. Further filling in the spaces between the spokes gives steadier, more continuous action, and changing the shape gives firm, constant contact. Now we can make the gears thicker and stronger, and we have differential gears. The edges are cut so that they will fit together more smoothly and silently, and another gear is added to share the work of driving the axles. The principle is the same. In order to turn the support and drive the wheels, we can fasten a large gear here, connected by a smaller gear to a source of power. Notice that the power is connected to the differential at the center line. We can make our model more compact by moving the gears closer together.
Power flow in differential. Drive shaft spins the pinion gear. Pinion gear turns the larger ring gear to produce gear reduction. The ring gear attached to differential case, hence, it rotates with the ring gear. Differential case spins the sun gears, which are attached to the axles. Axles transfer the power to the wheels. Types of differentials and their components. Types of differentials. Differentials can be generally classified into three categories: conventional or open differential, limited slip differential, and locking differential. Let us understand the operation and functions of each of these types in detail. Conventional or open differential. Function: splits engine torque into two outputs, each of which is able to rotate at a different speed. Working: torque is supplied from the engine via the transmission to the propeller shaft, which runs to the final drive unit that contains the differential. A spiral bevel pinion gear takes its drive from the end of the propeller shaft and is encased within the housing of the final drive unit. This meshes with the large spiral bevel ring gear, known as the crown wheel. The crown wheel and pinion may mesh in hyphoid orientation. The crown wheel gear is attached to the differential carrier or cage, which contains the sun and planet wheels or gears, which are a cluster of four opposed bevel gears in perpendicular plane. So, each bevel gear meshes with two neighbors and rotates counter to the third that it faces and does not mesh with. The two sun wheel gears are aligned on the same axis as the crown wheel gear and drive the axle half shafts connected to the vehicle's driven wheels. The other two planet gears are aligned on a perpendicular axis, which changes orientation with the ring gear's rotation. Advantages. On paved roads, this system is very successful, giving predictable handling, even tire wear, and requires very little maintenance. Disadvantages. When one tire loses traction, the opposing tire also experiences a torque reduction. In the worst case, the vehicle is stuck with one wheel freely spinning, while the tire with better traction can't deliver enough torque to budge the vehicle. The open differential is mainly composed of 6 parts. Differential case. It holds the differential gears, also carries the ring gear, so the surname is carrier. Pinion gear, attached to the housing via bearings, transfers power to the ring gear. Ring gear. Ring gear attached to the case via bolts to make the case rotate. Sun gears transfer the power from the case to the axle shafts. Planetary gears allow each sun gear to move independently of the carrier. Crawls over the sun gears. Differential crosspin holds the differential planetary gears in place, locks the sun gears in place, retains C-clips in the sun gears for some applications. Conventional or open differential. Let us now see how the differential functions during straight path and during turns. The vehicle moves straight. In this case, the spider gear rotates along with the ring gear, but does not rotate on its own axis. So, the spider gear will push and make both the side gears turn, and both will turn at the same speed. In short, when the vehicle moves straight, the spider side gear assembly will move as a single solid unit. Vehicle takes a right turn. Now, consider the case when the vehicle is taking a right turn. The spider gear plays a pivotal role in this case. Along with the rotation of the ring gear, it rotates on its own axis. So, the spider gear has a combined rotation. The effect of the combined rotation on the side gear is interesting. When properly meshed, the side gear has to have the same peripheral velocity as the spider gear. Technically speaking, both gears should have the same pitch line velocity. When the spider gear is spinning as well as rotating, peripheral velocity on the left side of spider gear is the sum of the spinning and rotational velocities. But on the right side, it is the difference of the two, since the spin velocity is in the opposite direction on this side. This means the left side gear will have higher speed compared to the right side gear. This is the way the differential manages to turn left and right wheels at different speeds. Vehicle takes a left turn. While taking a left turn, the right wheel should rotate at a higher speed. By comparing with the previous case, it is clear that if the spider gear spins in the opposite direction, the right side gear will have a higher speed. Limited slip differential components. This type of limited slip differential has all of the same components as an open differential, but it adds a spring pack and a set of clutches. Spring pack. The preload spring applies initial force to the clutch packs but still allows enough slippage in the clutch pack for normal differential operation. Clutches pack. Each clutch pack has the same number of clutch discs and plates. The clutch pack is designed to slip when some preset torque value is reached. When the vehicle is making a turn, a high torque, caused by the outer wheel rotating faster than the case, causes the clutch pack to slip. This allows the differential to operate in the same manner as a standard differential when making turns. The discs and plates slide against each other. Discs turning with side gears, plates turning with case, allowing different rotating speeds between case and side gears, and therefore, between rear wheels. Construction of limited slip differential. Apart from basic components of a standard open differential, a limited slip differential has a series of friction and steel plates packed between the side gear and the casing. Friction discs have internal teeth and they are locked with the splines of the side gear. So, the friction discs and the side gear will always move together. Steel plates have external tabs and are made to fit in the case groove, so they can rotate with the case. If any of the clutch pack assembly is well pressed, the frictional force within them will make it move as a single solid unit. Since the steel plates are locked with the case and friction discs with the side gear in a well-pressed clutch pack casing, and the clutch pack will move together, or motion from the casing is directly passed to the corresponding axle. Space between the side gears is fitted with a preload spring. Preload spring will always give a thrust force and will press clutch pack together. The bevel gears have some speciality. When torque is transmitted through a bevel gear, the system axial forces are also induced apart from the tangential force. The axial force tries to separate out the gears. So, during high torque transmission through spider side gear arrangement, a high separating thrust force is also transmitted to the clutch pack. This force presses and locks the clutch pack assembly against wall of the casing. Working of limited slip differential. The limited slip differential functions like a normal open differential during normal condition and during turns, but if one wheel is on higher traction surface, that is, wheel is slipping, the torque transmitted to it will be higher. So, the thrust force developed due to the bevel gear separation action also will be high at that side. Thus, the clutch pack at high traction wheel side will be pressed firmly and the clutch pack will be locked. So, power from the differential casing will flow directly to high traction axle via clutch pack assembly. On the other hand, the clutch pack on the low traction wheel side is not engaged yet. So, the power flow will be limited to that side. Therefore, the vehicle will be able to overcome the traction difference problem. Locking differential types. Function. With the differential locked, the connected wheels always spin at equal speeds. In sand, mud, and snow, a locked differential ensures that torque continues to flow to the wheel with higher traction. Working of locking differential. A locking differential is designed to overcome the limitation of a standard open differential by essentially locking both wheels on an axle together, as if on a common shaft, while still allowing them to rotate at different speeds when it is required. This forces both wheels to turn in unison, regardless of the traction available to either wheel individually. Advantages. Provides increased traction compared to open differential. Disadvantages. Acts like an open differential when not locked. Locking the differential on a high grip surface, such as dry pavement, makes it difficult to turn the vehicle and can spoil the drive line. The locking differentials can be of two types. Automatic locker, which locks automatically as per the road and driving conditions without the driver's input. Selectable locker. Driver's input is required to lock the differential. Automatic locker differential. Automatic locker lock and unlock automatically with no direct input from the driver. Some automatic locking differential designs ensure that the engine power is always transmitted to both wheels, regardless of traction conditions, and will unlock only when one wheel is required to spin faster than the other during cornering. They will never allow either wheel to spin slower than the differential carrier or axle as a whole. Automatic locker tend to create odd handling characteristics on the street, as they lock and unlock, and take some getting used to. Let us watch a video now to understand its working. Selectable locker differential. On-command or selectable locker is the best of both worlds, providing the benefits of a locking differential and an open differential. It uses a switch-activated electric motor, or vacuum diaphragm, or a cable or lever, to engage the locker. When an on-command locker is not engaged, it acts like a standard open differential, with none of the quirky handling characteristics of an automatic locker. When the on-command locker is engaged, the differential locks the axle shafts together, where it is now more like a spool with no differential of speed between the wheels of that axle. The on-command locking of the differential can be achieved in two ways. Locking the differential using the compressed air or vacuum. Locking the differential using the electric power. Air locker. Air locker use a pneumatically controlled locking mechanism to switch between an open carrier and a fully locked differential. Once installed, all it takes is the simple flip of a switch to go from an open differential that works well on the street to a spool that provides 100% traction to both wheels off-road. Selectable locker differential. The e-locker are selectable locker that can be engaged and disengaged on demand by simply flipping a switch, that is, mounted anywhere within the driver's reach. Unlike air locker that require an air compressor, the e-locker connects to any 12-volt source via the included wiring harness and sends power to a strong electromagnet that engages and disengages the locking mechanism to switch between an open carrier and a fully locked differential. Introduction to Eicher tandem rear axle. Eicher tandem differential assembly layout on vehicle. Eicher tandem differential assembly layout of a vehicle is shown on the screen. Eicher tandem differential assembly. The main components of Eicher tandem differential assembly is shown on the screen. They are front propeller shaft, inter-axle propeller shaft, rear axle assembly, and forward rear tandem axle assembly. Eicher tandem rear axle power flow. Torque is transmitted to both axles through inter-axle differential action. Torque, or the power flow, from the vehicle drive line is transmitted to the input shaft and the inter-axle differential spider. At this point, the differential distributes torque equally to both axles. For the forward axle, torque is transmitted from the helical side gear to the pinion helical gear, drive pinion, ring gear, wheel differential, and axle shafts. For the rear axle, torque is transmitted from the output shaft side gear through the output shaft, inter-axle drive line, to the drive pinion, ring gear, wheel differential, and axle shafts. Eicher tandem differential assembly. 440 drive head. Eicher tandem differential cut section. Inter-axle differential lock. An inter-axle differential or IAD works in a similar manner to the main differential, except it divides the power equally between the two axles of tandem, rather than the two wheel ends of an axle. The IAD lock is driver controlled. It also allows for speed difference between the two axles of the tandem. Differential lock. The differential lock is operated by a switch on the dashboard. The switch cuts the current, which opens a solenoid valve to provide the control cylinder with compressed air. The air operates on the control cylinder diaphragm via the thrust rod shift fork. The shift fork moves the diaphragm on the drive shaft to mesh with the flange on the differential housing. The sensor sends the signal to the instrument cluster when the differential lock is enabled. Thank you for watching.